I'll be going through a derivation of the quadratic formula. This won't take too long, but I think a lot of high school students tend to just use the formula without paying attention to the teacher when they're deriving it, or if they even derive it. They just use it without knowing how it came about, which I guess it's not a big deal because you don't really have to apply the derivation of it to be able to solve quadratic equations. But it is helpful to know, and it could motivate some other derivations for some other rules and formulas later on. So let's begin. So we start with an expression. So we have a polynomial, ax squared plus bx plus c, and that equals 0, right? And we want to solve this equation here for x. So this is a general form of a second degree polynomial where you have coefficients a, b, and c. And we set it to 0 so that we can solve for what the values of x could be. And we want to find a formula which works generally for such coefficients so that we can just use the formula without having to solve every single quadratic equation from first principles. So we'll get to the actual formula at the very end. So what we can do is, so we have this expression here. What we can do is divide by the coefficient of the x squared term. So let's just go ahead and do that. So when we do that, the a goes away at the front. And we have b over a as the new coefficient for x. And then c over a. And then that equals 0 over a, which is just 0. At this point, so I just want to play around with this expression. It's not too important to understand why I'm doing these things immediately. You might realize these steps, the necessity of these steps in hindsight. So this is the way I'm going to be manipulating this expression. So from here, what I can do is subtract this constant term from both sides of the equation. So nothing too special going on now. And now the interesting bit is we're going to be adding some term on both sides of this equation, but we have to add a particular term so that we can do some special things with it. And this is what you might recall as the method of completing the square, where we look at the coefficient of the x term, we halve that amount, and then we square that halved amount, and then add that value to both sides. So if you look at this, b over a, that's the coefficient of x. We halve that, so that's, so I'll just write it out, x squared. So we have this so far. And then we want to add half of that amount, or the square of that half. So it would be over 2a. And then you square that. So if I add it to one side, I have to do it to the other side as well to balance the equation. All right, and so the reason we did that, right, is to be able to complete the square. So we can write this left-hand side as squared, so there's two factors, you can make it a square. So if you expand this over here, If you expand this, you'll realize that you'll just get back this. So that just equals, what am I going to do? I'm not going to do anything yet. So just rewrite the right-hand side, b over 2a squared. Okay, now I can take the square root of both sides. So I'll square root, so take the square away from the left-hand side. And then when we do that, we have to take the positive and negative of the square root of negative c over a plus b over 2a squared. Okay. So, yeah, so you might notice there are different features of this expression right now that look like the final result we're looking for, which is the quadratic formula. So let's simplify things a little bit. So let's take that b over 2a to the right-hand side. So it's negative b over 2a. And you have a plus and minus, square root. And I could write everything as a common factor. I'm going to use, because we're taking the square of this denominator, so I'm going to put it all over 4a squared. Which means I have to multiply this negative c by 4a. Right, so here what we notice is when we're taking the square root of this denominator here, that's just going to go to 2a. So if that goes to 2a, then our entire denominator is 2a, and we could put this negative b over there, take the plus and minus, and I'm just going to rewrite the negative 4ac plus b squared in the reverse order. And there you have it. That's your quadratic formula.